So this video we're focusing on solving radical equations by hand. Now remember, when you're solving almost any equation like we saw in the previous video, you can always use graphing when in doubt. But remember, sometimes graphing doesn't work, so it's always important to focus and make sure you know how to do things by hand as a backup method. A couple things, we're talking about radical equations. So radical just means you see this check mark symbol. That check mark symbol is called the root, and typically we're going to have a number in front of the root called the index. I use n for index, so it kind of sounds the same. Sometimes though, you're just going to see a regular check mark, aka a regular root, and that's called the square root. When you do not see a number in front of the root symbol, that's called the square root, and the index is always 2 for square roots. There's a couple different things here. So when the index is odd and your number underneath the root is positive, then you have one solution. When n is even and x is positive, then you have two possible solutions. And when n, your index is even and x is negative, then you have no real solution. So you would see that if you did it graphically. So to solve a radical equation, the index n and the power that you use to cancel it out must match. It's got to. The very first thing when you want to do that is to get your root piece by itself first. So, for instance, in example 5, I'm going to start off by saying plus 4 on each side, because I've got to get that cubed root of x by itself first. As soon as I do that, I see that my index is 3, so that means I'm going to need power 3 on each side, because what you do on one side, you've got to do on the other, to cancel it out. So power 3 and index 3 will cancel out, and that leaves me with x equals the 4 to the third power. But 4 to the third power is 64, so x equals 64. Again, you have to get your root by itself first. So in this example 6, my first step is going to be to subtract 2 on each side. So I have the square root of 4x minus 7 equals 3. Now, like I just said a few minutes ago, anytime you just see a regular root, aka the square root, the index is always 2. That's just a rule. As soon as we know that, we know we're going to need power 2 on each side to cancel it out. So power 2 and index 2 cancel out, and that leaves me with 4x minus 7 is equal to 9. Well, now I can easily solve this equation. I'm going to say plus 7 each side. I have 4x is equal to 16. Now I'll finish it off by dividing by 4. And that tells me that x equals 16 divided by 4, which is just 4. Okay, in our final equation, our final problem, we have two radicals on the same side. That can't happen. At most, only one radical per side allowed. So what I need to do is take this 2 square root of x over to the right-hand side. Now I chose to move that one because it's kind of a little bit smaller, probably going to be easier to work with. So to do that, I'm going to say plus 2 square root of x on each side. So square root of 3x plus 2 is equal to 2 square root of x. Now, since these are regular square roots, I know that the index for each one is 2, and since I know that the index is 2, I know I'm going to need power 2 to cancel it out. So power 2, index 2 cancels out, so 3x plus 2 just falls down. Here, power 2 and index 2 cancels out, so x falls down, but this 2 that's on the outside also gets power 2, so 2 squared is 4. If you do not say 2 squared is 4 there, then this problem's not going to come out correctly. Now, I need to get my x's on one side and keep my constants on the other, so I'm going to take 3x over to the right. So minus 3x each side. So I have 2 equals 1x, divide by 1. So that tells me that x is equal to 2 over 1, which is just 2. Okay, no big deal, solving radical equations. Let's do a few more examples. Sometimes you're going to have what's called a power equation. So to solve a power equation, you simply need to take whatever power you're given. To cancel it out, you need to flip the power. So let's do this problem. Now, before you can do that though, you have to get the piece with the power by itself first. So for in example 8, I have to get rid of the 3/4 before I can do anything. I'm going to do this in 2 steps. You could technically do it in 1, but just to help out people who might struggle a little bit, I want to do it in 2 steps. The first step is always multiply by whatever number is on the bottom of your fraction, in this case 4. So multiply by 4 on each side of the equation. The 4's are going to cancel out, so I'm just left with 3x to the 1/3 power. Negative 2 times 4 is negative 8. Again, I need to get the piece with the power by itself, so I got to get rid of the 3. To do that, I'm going to divide on each side. So x to the 1/3 power is equal to negative 8/3. Now, like we just saw above, to cancel out the 1/3 power, I'm going to have to flip that fraction and use that power on each side. So I'm going to have to use the 3/1 power on each side. 1/3 power and 3/1 power are going to cancel out, so x is just going to fall down. So x is equal to negative 8/3 to the 3/1 power. Well, that's kind of messy, so let's see if we can do any better. Clean it up in our calculator. I'm going to type it in exactly the way it looks. Since negative 8/3 is a fraction, it goes in parentheses. That's super important. Don't forget that. And I have a fraction for a power, so that needs to go in parentheses as well. Don't forget that. And I get a decimal, so let's go 2 decimal places. So x is about negative 18.96. Okay? It didn't really get too much cleaner, but this decimal definitely looks better than this nasty fraction. Okay, another example. So remember, if the power in the problem is even, 2, 4, 6, 8, etc., then you're going to have to consider 2 possible solutions. And as always, we've got to start off by getting the piece with the power by itself first. So in this particular problem, example 9, I'm going to divide by 3 on both sides before I do anything else. So when I do that, I get x squared is equal to 81 divided by 3, which is 27. If you can't do that in your head, please, I beg you, take a few seconds and do that in your calculator. Okay, no big deal. Again, our power in this problem is even, so like we just said, we got to consider 2 solutions. So that means when I take the square root and cancel it out, or sorry, not square root, I'm thinking of something else. First off, we want to write 2 as a fraction. 2 is a fraction, so 2/1. That tells me I'm going to have to use the 1/2 power on each side to cancel it out. But when I do the 1/2 power, since I have 2 solutions, I need to think about plus or minus. So really, 2/1 and 1/2 power, those cancel out, so I have x equals plus or minus 27 to the 1/2 power. Now, technically, you could leave it alone like this, or if you don't like plus or minus, you can split it up. So x equals positive 27 to the 1/2 power, and x equals negative 27 to the 1/2 power. Now, 27 was our base. It has to be in parentheses. The negative does not go in parentheses with it. Super, super, incredibly important. If you put that negative inside parentheses with the 27, it's going to come out wrong. Okay? Now, what I'm going to do is convert each of these into a decimal, just using my calculator. So I have base 27 inside parentheses raised to the 1/2 power. Again, that power is a fraction, so it goes in parentheses. And I get 5.20 if I round. Okay, so that's this solution here. And then I want to find my other solution using my calculator. So again, the negative stays on the outside of the parentheses, so then type it in. Don't forget the parentheses that you need. Make sure you type it in correctly. And so I get negative 5.20. And then sometimes when we solve equations, we can end up with an extraneous or what's called a false solution. This is particularly true with radical, rational, and logarithmic equations. So those type of equations that you're going to see now and in the future, be sure you go back and check your answers. So first off, I want to solve this one. Here's an example. I have a square root, so that means I have an index of 2. Since I have an index of 2, that means I'm going to need to use power 2 on each side. Now, there's more than one thing on the left, so you've got to put it in parentheses before you do that power 2. Power 2 and index 2 is going to cancel out, so I have 2x is equal to parentheses x minus 4 squared. Now, I want to do some scratch work on the side over here in red because I need to figure out what x minus 4 is. X minus 4 squared is. I'm going to use the box. You can use FOIL if you like. So I have x times x, which is x squared. X times negative 4 is negative 4x. X times negative 4 is negative 4x. And negative 4 times negative 4 is positive 16. So I'm just going to combine like terms now. X squared minus 8x plus 16. So this piece over here becomes x squared minus 8x plus 16 equals 2x. Now I see a quadratic, so I remember from previous classes, like I hope you do, that to solve quadratics you need to start off by getting everything on the same side. So minus 2x on each side. So x squared minus 10x plus 16 equals 0. Now, I want to solve this by factoring. If you're not good at factoring, you need to get better. So go back and watch those videos about factoring, okay, because that's really a skill you should have before you come to this class. So I'm looking at x minus 8 and x minus 2, and that's still equal to 0. I'm going to double check, make sure I have the right numbers for my factorization. So first off, I'm going to multiply negative 8 times negative 2, which is positive 16. And then I'm going to double check it by adding negative 8 plus negative 2, which is negative 10. That works out, so I have the right factorization. Now I want to use the zero product property, which essentially it says if you have everything set equal to 0 and you have a product, then you can set each factor equal to 0. Okay, and then you just solve each equation. So plus 8 on each side for the first equation. So x equals 8. Plus 2 on each side for the second equation. So x equals 2. Now, you got to be careful because since we had a radical equation that we started with, these are only possible solutions, so we need to check them. So to check them, what I'm going to do is actually plug in. I want to plug in x equals 8 into my original problem. This is just scratch up on the side. I'm doing it in yellow. So 8 minus 4 is equal to the square root of 2 times 8. 8 minus 4 is positive 4, and 2 times 8 is 16, so the square root of 16. We know the square root of 16 is 4, though, so 4 is equal to 4, which is true. What that means is that x equals 8 is a valid solution. Valid is just a fancy math name for a true solution. Now we need to check the other solution, possible solution, x equals 2, by plugging into the original equation. So I'm going to do that in purple. So I have 2 minus 4 is equal to the square root of 2 times 2. Everywhere I see an x in the original problem, I'm just plugging in my possible solution. 2 minus 4 is negative 2, so negative 2 is equal to the square root of 2 times 2, which is 4. Well, we know the square root of 4 is positive 2, but this is saying negative 2 is equal to positive 2, which we know is not true. So this means that x equals 2 is an extraneous or a false solution. Extraneous is just a fancy math name for false. So what we're going to do is throw out that solution. The only solutions that we keep are valid solutions. And that's it for this video. If you need help, as always, please let me know.